Hello, my name is Rick Crow and I am from East Carolina University. I will be presenting a brief review of threats and security for DNS for the ICTN 6870 Advanced Network Security class. The Internet of Things has caused an explosion in the number of devices that are now connected to the Internet. According to Cisco, the number of devices connected to IP networks will be 3 times as high as the global population in 2021. With that said, the majority of these devices utilize the domain name system in some form or fashion. I'm sure everyone is aware of what DNS is and what it is used for, but you may not be aware of the threats that DNS infrastructure faces or the security solutions that have been developed to help protect it. The agenda for this presentation is as follows. We'll define some key terms, overview some threats facing DNS, overview DNS security solutions that have been developed, and provide some methods of improving DNS infrastructure security. Key terms that will be useful for this presentation: an authoritative name server is a server that has ownership and control of a particular DNS zone and stores the actual DNS records for that particular DNS zone. Authoritative name servers are responsible for providing answers to DNS queries. A resolving or recursive name server is a server that receives DNS queries from clients and then queries authoritative name servers for the answer to the query and subsequently returns the answer to the client. A DNS resolver is a DNS client that resolves individual host names to IP addresses. This is generally a program that runs on a host operating system. Resolvers are responsible for querying name servers, interpreting responses, and returning requested information to the program that requested it. Recursion is the process of repeatedly querying name servers and then following referrals until finding the authoritative name server with the answer. There are many facets to DNS, but these basic terms are adequate for the information in this presentation. First, let's talk about the threats that face DNS. One of the top threats facing computer systems and their users is malware. Malware is spread through emails, malicious websites, and other methods which all use DNS. Not only is DNS used to distribute malware, it is also utilized within the malware itself. One method of blocking malware distribution is blacklisting the IP addresses of known malware distributors. In order to circumvent this, malware authors leverage DNS instead of IP address to establish communications with command and control servers to receive further instructions about what to do next. Not only can malware utilize DNS to establish communications with command and control servers, it can utilize DNS to send an organization's data out of their network. The malware accomplishes this by breaking the data down into chunks and then sending the data to malicious DNS servers as DNS queries. The malicious DNS servers are then able to reassemble the stolen data. One of the most common methods of attack against DNS servers are distributed denial of service attacks. Because DNS is such a critical piece of network infrastructure, it is an attractive target for malicious users. If DNS is not functioning, all of the services that rely on it can't function. The DDoS attack on DIN's DNS servers in 2016 demonstrated this fact. DIN, now Oracle DIN, was a DNS provider that hosted DNS for a large number of big companies like Amazon, CNN, BBC, Reddit, Twitter, and many other companies. The attackers leveraged a massive DDoS attack against DIN's DNS servers that effectively crippled large portions of the Internet because the DNS servers were unable to effectively resolve queries. There are 3 kinds of DDoS attacks that are typically leveraged against DNS servers. The first technique is called an amplification attack. In an amplification attack, attackers will send small queries to an authoritative name server that can trigger a larger response than the initial query. Botnets are typically used to send a flood of these small queries, and eventually the DNS server is so busy trying to send the larger responses that eventually it will get overwhelmed and become unresponsive. The second technique is called a reflection attack. In a reflection attack, attackers will send queries to a recursive name server with a spoofed IP address. The source address will be the target of the attack. Typically, these queries will trigger larger responses than the initial query and will be sent in such great numbers that the target network gets overwhelmed with the size and the amount of traffic that is generated. The third technique is called a combination attack. As you can probably guess, this technique involves both amplification and reflection and is used to target multiple victims. Just like any other software, DNS software is not immune to exploits and protocol weaknesses. These exploits and weaknesses can be leveraged to corrupt the cached answers that are stored on recursive name servers. This type of attack is called DNS cache poisoning or DNS spoofing. The goal of this type of attack is to implant false information into the DNS cache that will direct users to malicious destinations. Now that you have an idea of the threats that face DNS, let's take a look at some of the security solutions. When the domain name system was initially designed, the developers did not have security in mind. However, since its creation, there have been some security solutions that have been developed to help protect it. Response rate limiting, or RRL, is a method to limit the query response rate of a DNS server in order to mitigate distributed denial of service attacks. This is achieved by assigning a token bucket to each client that queries the server, then issuing a token for each request that the client makes. And then once the bucket is empty, utilizing a wait time before the bucket gets refilled. This wait time is insignificant enough for normal users, but makes a DNS server that is configured with RRL an unattractive target for attackers. DNS security extensions are a suite of specifications for adding security mechanisms to DNS that adds integrity to the DNS process. DNSSEC uses public key cryptography to authenticate DNS data, which gives DNS infrastructure the ability to verify the sender of the data and protect against cache poisoning. DNSSEC does not encrypt DNS data, nor does it provide confidentiality or availability of DNS data. As I stated previously, malware is a big threat to computers, systems, and their users. And DNS can be used to not only spread malware, but be utilized in malware. The idea behind response policy zones, or RPZs, is if malware can't resolve a DNS query, then it can't reach out to command and control servers or other malicious content to further infect a system or exfiltrate data. RPZs leverage policies and reputation to evaluate DNS requests made by clients, and if a domain or a site has a bad reputation, then the client can be blocked or redirected to another page. Additionally, administrators can also be alerted to initiate remediation actions on the infected client. In their book, DNS Security for Dummies, Kuo, Nagy, and Liu provide 10 keys to improving DNS security. Some of these are self-explanatory, like keeping software patched and updated, maintaining backups, eliminating single points of failure, securing servers inside your perimeter, and automating security tasks when possible, as these are things that should be done for any system or application. For DNS infrastructure, they specifically recommend utilizing dedicated DNS hardware or software that is preferably a full-blown IP address management solution that has the capability to configure response policy zones, resource rate limiting, DNS security extensions, and can leverage threat intelligence information to help secure the environment. They recommend a dedicated solution with full-blown capabilities because it is simpler to manage and maintain a dedicated system as opposed to a system that uses a standalone operating system with an application running on top of it. They also recommend disabling DNS recursion or limiting it as much as possible in order to limit your attack surface and the exposure of your DNS infrastructure. As defined earlier, recursion is the process of repeatedly querying name servers and following referrals until finding the authoritative name server with the answer. If If you allow recursion from anyone, then your DNS servers can be used in attacks against other organizations and can be used to provide attackers information about your own organization. The domain name system is a critical part of the Internet's infrastructure. Without DNS, we would not be able to translate human-friendly names into the IP addresses associated with computer systems. It is important to understand the threats that face DNS and some of the security solutions that have been developed to help protect it. Here are the references that were utilized for this presentation if you would like to do further research. Thank you.